Happy New Year and thank you for watching. How to become a machine learning engineer. How is machine learning useful? If you are a complete starter to machine learning, this video will walk you through steps to achieving your dream. Machine learning is an emerging career path that relates with software engineering, data exploration, forecasting, and mainly problem solving. The role of a machine learning engineer is to gradually finding its way to becoming the hardest in IT field. According to Robert Half Technology, the future of work and how technology will transform jobs reveals that 30% of surveyed US managers said their company is currently using AI, artificial intelligence, and machine learning (ML), and 53% expect to adopt these tools within the next 3 to 5 years. Hey, to be notified on related videos, subscribe to this channel for more updates. As more organizations begin to explore and invest in machine learning and artificial intelligence, they are looking to hire more experts to integrate these technologies into their business initiatives. But what exactly is machine learning? Machine learning is a field of computer science which aims to build programs that complete a task, not by explicit instructions but learning from data and patterns. It mainly provides algorithms and models that applications can use for training purposes. What does a machine learning engineer do? In practical terms, the job of a machine learning engineer is close to that of a data scientist. Both roles work with vast quantities of data, require exceptional data management skills, and the ability to perform complex modeling on dynamic data sets. But here the similarity ends. Data professionals produce insights, usually in the form of charts or reports, that are presented to a human audience. Machine learning engineers, on the other hand, design self-running software to automate predictive models. Each time the software performs an operation, it uses those results to carry out future operations with a greater degree of accuracy. This is how the software machine learns. A well-known example of ML is the recommendation algorithm of Netflix, Amazon, and other consumer-facing services. Each time a user watches a video or searches for a product, these sites add more data points to its algorithm. As the amount of data grows, the algorithm's recommendations to the user for other content become more accurate, all without any kind of human intervention. ML is closely related to AI, and ML encompasses deep learning. DL, this subfield uses artificial neural networks to think and solve complex problems with multi-layer deep data sets. Some common examples of DL include virtual assistants, translation apps, chatbots, and driverless cars. Over time, these technologies will become even more accurate and practical. Why machine learning engineers are in demand? Businesses today are awash in data, from customer interactions to IoT networks. Attempting to process all that information manually is like drinking from a fire hose. Machine learning has become essential for taking full advantage of a company's data. Applications of ML are as varied as the data itself. A few common applications include 1. Image and speech recognition. Machine learning excels at auto-tagging images, text-to-speech conversions, and anything else that requires turning unstructured data into useful information. 2. Customer insight. Association rule learning. The way ML software makes connections drives the algorithms at the heart of e-commerce, telling consumers who buy a product A that they might like product X. 3. Risk management and fraud prevention. ML algorithms can analyze huge volumes of historical data that make financial predictions from future investment performance to the risk of loan defaults. Regression testing also makes it easier to spot fraudulent transactions in real time. What to expect in a machine learning engineer job description? Because ML is an emerging role, not many IT specialists have direct experience with it. That's why most machine learning engineer job descriptions today seek out data scientists with a programming background. The reverse can also be true. Coders and programmers with solid data skills can transition to become machine learning engineers, though they may need experience in the data role beforehand. A job description for machine learning engineers typically includes the following: advanced degree in computer science, maths, statistics, or a related discipline, extensive data modeling and data architecture skills, programming experience in Python, R, or Java, background in machine learning frameworks such as TensorFlow or Keras, knowledge of Hadoop or another distributed computing systems, experience working in an agile environment, advanced math skills, linear algebra, Bayesian statistics, group theory, strong written and verbal communications. Popular job titles that are closely related to machine learning engineer are 1. Big data engineer, 2. Data architect, 3. Data scientist, 4. Data modeler, 5. Developer, programmer analyst, 6. Software engineer, 7. AI engineer, 8. Deep learning engineer. Excited about what machine learning can achieve? Let's look at the learning paths to making you a machine learning engineer. Step 1. Basics of R and Python. There are multiple languages which provide machine learning capabilities. Also, there is development work happening at a rapid pace across several languages. Currently, R and Python are the most commonly used languages, and there is enough open source resources available for both. Before entering into the world of ML, I would recommend you to choose one of these two languages, R or Python, which can help to focus on machine learning. Which is better, R or Python? Keep your focus on understanding the basics of the language, libraries, and data structure. Other languages you can consider are Scala, Go, Julia, and coming time. Step 2. Learn basic descriptive and inferential statistics. Make sure to refresh on statistical learning. It is good to have an understanding of descriptive and inferential statistics before you start beginning machine learning development. Udacity offers courses on descriptive statistics and inferential statistics. Both courses would make use of Excel to teach you all the basics of statistics. Step 3. Data exploration, cleaning, and preparation. What differentiates a good machine learning professional from an average one is the quality of feature engineering and data cleaning which happens on the original data. The more quality time you spend here, the better it is. This step also takes the bulk of your time and hence it helps to put a structure around it. If you find this video interesting, hit the like button or give a thumbs up to help other viewers find this video. Step 4. Introduction to machine learning. Knowing the basics of machine learning is very vital. There are various resources available to start with machine learning techniques. I will suggest you pick one from the numerous MOOCs that works for you. Step 5. Participate in Kaggle Knowledge competition. For practice, the Kaggle section has plenty of datasets you can play around with, and it comes with handy upvote features and previous projects so you can see what the most popular datasets are and how people have wrangled with them in the past. By now, you have all the tools you need to compete on Kaggle Knowledge competitions. These knowledge competitions have less difficulty level as compared to prize-winning challenges. You can also find various related resources to kickstart your data science journey. Step 6. Git and GitHub, Docker, APIs. You will want to get a handle on how to use Git and GitHub efficiently in order to collaborate across different code bases and across different models quickly with different teams. Docker containers will let you share applications with all the dependencies packaged and are essential software development collaboration tool. You want to get a handle on Docker and use it to help share the software you've developed. You also want to learn how to build and access APIs easily. There are a systematic set of rules for both getting data and for letting others pull it. Step 7. Spark and Hadoop. You want to train with a distributed data programming framework that will help you handle the load of big data sets that might go into the petabytes. If you want to get started with Spark, there is a Spark implementation in Python known as PySpark, and plenty of documentation and tutorials involving Spark, especially with Databricks. Spark ML is a very popular large-scale machine learning framework. The argument can be made that Spark is the future and Hadoop is the past. If you believe that, focus on building your Spark skills. Step 8. TensorFlow. Learning the TensorFlow framework and other deep learning libraries such as Keras will allow you to harness the power of neural networks and reinforcement learning. Step 9. Data storage and pipelines. Once you've mastered the tools required to ingest data at scale and then work with it with different machine learning approaches, you want to stitch all kinds of different tasks together in order to build a coherent data pipeline. Consider something like Spotify's Wiggy framework. It helps you deal with the low-level plumbing so you can focus on the high-level strategy of what you want your machine learning pipeline to do. You also want to have a fairly good understanding of how to operate with SQL and NoSQL databases. Step 10. Advanced machine learning. Now that you have learned most of machine learning techniques, it's time to explore advanced machine learning techniques to understand different structure of data like deep learning and machine learning with big data. Deep learning. You need a good knowledge of deep learning to become a classic machine learning engineer. Ensemble modeling. This is where an expert is different from an average professional. Oh yeah. Ensembling can add a lot of power to your models and has been a very successful technique in various Kaggle competitions. Machine learning with big data. As you know, the size of data is increasing at an exponential rate, but raw data is not useful till you start getting insights from it. Machine learning is nothing but learning from data, generating insights or identifying patterns in available datasets. There are various applications of machine learning algorithms like spam detection, web documents classification, fraud detection, recommendation system, and many others. The best way to learn machine learning: never stop learning, never stop studying. If you really want to learn machine learning and actually forge a successful career in the field, you must be prepared to pursue the subject for the long term. It is a fast-moving field and there is no room for complacency. By taking a self-starter approach, you can progress faster and learn more practical uses and skills than any textbook will show you. From forums and videos to competitions and collaborative projects, there is no end of great machine learning resources for you to learn from. It all comes down to your will and passion. With a proactive attitude, you're sure to find a path forward. Hopefully you find this learning path on becoming a machine learning engineer useful. If you want your guidance or more guidance on improving your analytical skill, or ready to transition to a role in this cutting edge field, visit DataCatchup.com for more details. Also make sure to subscribe to this channel for more data science videos. Interested in your career growth in data science? Visit DataCatchup.com. Also make sure to subscribe to this channel for more data science videos.